Hello, this is Jack Jackson. In this video, we're going to talk about the effect of sample size on t-test and t-interval. We will address the relationship among the sample size p-value of a t-test and the size of the t-interval. Small p-value versus large differences in the mean. We got to be sure we don't confuse some things here. While it is true that the larger the difference between the sample mean and the hypothesized mean, the smaller the p-value will be sure to not confuse strong evidence, a very small p-value, of a sample coming from a population with a different mean than given in the null hypothesis with the mean of the population from which the sample is derived being greatly different from the hypothesized mean. The relationship here depends on the sample size. For example, we could have a null hypothesis of mu equals 10 and a p-value of 0.0001, 3 zeros and a 1, for a right-tailed t-test. This indicates that we are very sure that the true mean of the population producing our sample is higher than 10. However, it does not indicate how much higher the mean is over 10. If the sample size was large, it might be that the true mean is 10.5. Perhaps that's not much higher than the hypothesized mean. However, it does give strong evidence. Note that as we increase the sample size, it does make it much surer that the sample mean is close to the actual mean. We see that if we have a large sample size and the null hypothesis is true, then it is unlikely that we will have a sample mean significantly different from the hypothesized mean. However, if the alternative hypothesis is true, it is likely that we will have a sample mean that is statistically significant different from the hypothesized mean when we have a large sample size. However, also notice that as we increase the sample size and keep a particular confidence level fixed, the margin of error for confidence interval decreases. So, when we have a large sample size, we can sometimes correctly conclude that the null hypothesis is false and the mean is different from the hypothesized mean. However, this difference might be very small. If the sample size is very large, it may turn out that we are very sure that the mean is very slightly different than that given in the null hypothesis. Statistical significance and practical significance are not always the same thing. So to address this potential problem, the best thing we can do when performing a test of hypothesis, especially in the case where we reject the null hypothesis, is that we should also give a confidence interval for the mean as well. The combination of a hypothesis test with a confidence interval is very powerful and much more informative than either the confidence interval or the hypothesis test by itself. At this point, I would suggest that you turn to your textbook and study sections on t-tests and t-intervals, both the one-sample versions and the two-sample versions, if you haven't done so already. In our current textbook, the two-sample versions, I believe, are in sections 10.1, 10.2, 10.3, and 10.5. I also encourage you to go along to read the rest of Chapter 10 along with sections 9.6 and 9.8. Earlier, I have assigned the other sections of Chapter 9, but the other sections in Chapter 10 and these two sections in Chapter 9 cover non-parametric statistics, at least our current textbook, and these will not be part of my first course in Probability and Statistics 1. However, they are very good topics to know.